Alright, let's look at the homework 3.3, problem number 5. Alright, so first, part A, we want to find the critical numbers of the function f of x equals x to the 6th times quantity x minus 2 to the 5th power. Alright, so let's do that. Alright, so first we have to take the derivative. So f prime of x is equal to, alright, so we're going to use the product rule. So here's the first guy, here's the second guy. Alright, so derivative of the first guy is 6x to the 5th times the second. So you have x minus 2 to the 5th power plus x to the 6th power, then multiply by the derivative of the second guy. So 5 in front, x minus 2, raise it to the 4th power, and multiply by derivative inside, which is 1 anyway. Right? Then let's factor out. So let's look for the common factor. So you have x to the 5th here and x to the 6th. So I'll take 5 of those, then put it down here. So you have x to the 5th power. And also you have a quantity x minus 2 to the 4th, and we have those two. So you have x minus 2 to the 4th power. Right? Seems like that's all you have. So you have, let's say, 6x minus 12 and plus 5x, and that's it, right? So 5x. Right, so this is going to be equal to x to the 5th times quantity x minus 2 to the 4th power, and that will be 11x minus 12. Right, so set that equal to 0. We will get right, x equals 0. From here 2. From here 12 over 11. Right, so from the smallest value, so that will be 0, and the next one is 12 over 11 and 2. Right, so let's type that in. Right here it's 0 and 12 over 11 and 2. Alright, so let's go to the next part. We want to do a second derivative test, so we have to take the second derivative. Alright, so let's do that. Alright, second derivative, so it seems like we have three things multiplied together. Alright, so remember that if you have, say, three things multiplied together, say f times g times h, then if you take the derivative, all you have to do is take the derivative of the first guy and multiply by the second and third, and the first guy times the derivative of the second times the third, and the first times second times derivative of the third. Right? So that's basically the product rule twice. So let's do that. So f double prime of x is equal to, right, derivative of that first. So you have a 5x to the 4th times x minus 2 to the 4th times 11x minus 12 plus derivative of the middle guy. So it's x to the 5th times 4x minus 2 cubed times 1, and then 11x minus 12. Right, then last guy, derivative, so write down x to the 5th and x minus 2 to the 4th. Derivative of the last guy is 11. Right, so let's take the common factor. Alright, so common factor would be here, x to the 4th, and let's see, looks like, so there's 5 of them, so I'll just take 4 of them, and the same here. So we have x to the 4th power. Alright, then what else? So here we have x minus 2 cubed, so you have 4 of them here, so I'll take 3, and 4 of them here, so I take 3. So you have x minus 2 cubed. Alright, then I don't think we have anything else in common, so we're going to have to just kind of multiply it all out. So let's see, I'm going to do, so here's 5 times, alright, so we're going to have to multiply these. So we're going to get, let's see, 11x squared. Alright, so that's going to give you negative 12, and then you have a negative 22. Alright, so negative 12 plus negative 22, so it's negative 36, and that, oh, actually 22 and 12, so 34. Sorry about that, I'm slow. Alright, and negative 2 times 12 is plus 24. Alright, so we have that. And here we have 4x times that, so it's going to be 44x squared, and minus 48x. And here plus 11x squared minus 22x. Alright, so we have that. Alright, it's really yucky, but collecting the like terms, so you have x to the 4th and x minus 2 cubed. Alright, so collecting the like terms, we have 55x squared here, and 44x squared, and 11x squared. So that would be 110 x squared, right? Right, so let's see, 5 times negative 34, so that would be 4 times 5 is 20, and so 3 times 5 is 15, so it's going to be negative 170x, right? And a minus 48x, so that would be negative, let's see, 218x. And then you have negative 22, so that would be negative 240x. Right, that will take care of this guy, and that guy, and that guy, and along with 5 there. And the last one is only constant term is 5 times 24. So that would be, so 4 times 5, 20, so it's 120. Right, so we have that. So at least everyone has 10 in common, so I'll pull out 10. So 10 is out here. So you have x to the 4th times quantity x minus 2 cubed. Then you have 11x squared minus 24x plus 12. Right? So this is a second derivative, so I'm not sure if I can factor this out, but personally I don't really care. Alright, so let's look at the second derivative at critical numbers. Alright, but you notice that if you plug in 0, that's going to be 0. So second derivative test is inconclusive. And also x equals 2, it's inconclusive. So only interesting one would be the 12 over 11. So 12 over 11. Right? We're just interested in the sign. Right? So here, this guy is always positive because it's the fourth power, right? So 12 over 11 minus 2 would be negative. Negative cube is negative, so this part is actually negative. Alright, so this is a tricky one. Let's see, so let's compute that. And if you plug in 12 over 11 here, so one of the 11 cancel out. So 12 squared is 144 over 11. Alright, so it's negative 24 times 12 over 11, so that's what the bottom is 11. So 2 times 24 would be 48. Then 1 times 24 would be 24, so 288. Right? Plus 12 is equivalent to 132 over 11. right? So that will be, so it's going to be 276 over 11 minus 288. Okay, now I know that it's going to be negative, right? So this guy is actually negative, right? So we have positive times negative is actually positive, right? So which means that the graph is concave upward, so we're looking at the shape like that. Then critical number is here, so we're looking at the bottom of the valley, which means that it's going to be a local minimum, right? So let's put that in. So at 12 over 11, this guy is going to be local minimum, right? Then what does the first derivative test to tell you about the other two guys? So it's going to be, of course, this is 0 and 2, right? So let's look at that. Alright, so first derivative test. So we're going to do a number line, right? Then you have 0 here. And also, let's see, between that you have 12 over 11. And you have 2, right? So we just want to know the sign, before 0 and after 0. So let's look at that. So we can try anything like x equals -1 would be good. And between 0 and 12 over 11 would be 1. X equals 1 would work, right? So let's look at the sign, just a sign, right? So we have, so I'm going to look at this, right? So this guy, so if you plug in negative number, negative to the 5th is negative, right? This guy is always positive because it's got the 4th power, right? So if you put the -1 here, so negative 11 minus 12, so it's negative, right? Negative times positive is positive. So you have a positive sign here, right? And at 1, it's a little different. So x to the 5th, 1 to the 5th is positive. This guy is always positive. And 11 times 1 minus 12 is still negative. So you can see that this is negative there, right? So you can see that from here, it's increasing turning to decreasing. So which means that this is going to be a local max. So here you would have local max, right? So let's type that in. Here we're going to have a local maximum, right? So how about 2? Right, 2, so we're going to have to do a sample number. So it has to be between, let's see, 12 over 11. So we can try like 1.5. And after 2, we can try like a 3, right? So if you put the 1.5, then here you can see that that will be positive, right? And that's always positive. Here, 1.5 times 11 is definitely bigger than 12, so it's going to be positive. So you can see that everyone's positive there, right? And after that, and after 2, so you try 3. So if that would be positive, this is always positive, and put 3 there, that's positive, so it's positive again, right? So the derivative doesn't change sign, so this is going to be right here. This is going to be neither, right? So we're going to put here. So this is going to be neither, right? So let's submit for testing. Alright, it came back and it looks like we got all these guys correctly. Alright, that's it. I hope that this was clear.